talk about using df.describe, really df.info to look at the statistics, but what else can we do, right? And we'll talk about even the histogram as well. So histogram now looks like that because we got rid of a bunch of outliers. And then box plot definitely is very useful. So what if we want to look at the correlations or the relationships of different columns, right? So one way of doing this is using Seaborn's pair plot, which is very, very handy. You need to know this. And then what we can do is, maybe I'll just type it out in here, SNS dot pair plot, and then what you're passing inside is really just a DF, slice version of DF, or you can pass the entire DF, but I will, because we have so many columns, so I will just select a few, right? You can actually say, I want these 2 columns, right? Remember, you need to do the double square parentheses, right? When you want to only grab, say, few columns from the DF. So then I can actually add more if I want, like year built, right? So this will give me the pair plot. It's going to take some time to run. Okay, so now this is a pair plot. It looks somewhat not so great because it's all like big cluster. So what if I do something like this, right? So like you can see that visualization takes a lot of iterations. You want to try out different things, right? One cool thing about pair plot is you can add this thing that's called hue, which I use a lot. So this is just this will allow you to have the color overlay. So let's try this, right? So I said I want, the hue as zip code. Then you can pretty much see, okay, so with zip code being pink, that's like 80209, you will have different color overlay, right? So, and then you have all these type of, we did the zip code .unique to tell you this is the unique zip codes, and you have different color overlay. And then from here, what I can see is the first thing is diagonal, right? So the diagonal ones are actually to itself. So pretty much this is to say last sale amount versus last sale amount, right? All of them are pretty much like in here, or just because we didn't get rid of the outliers. So this is pretty much to tell you the histogram, right, of that. So you can see that this estimate value versus estimate value is the histogram on its own, and that it's pretty normal, right? And then in here, this is to tell you most of the houses that we're getting in this data set are coming from this one zip code, right? This is the biggest zip code. And then what happened to the relationships, right? So what if we want to say this is the estimated value, right? And then based on different zip code, right, you can actually see the estimated value. Definitely this one, because most of the houses are coming from this zip code, you can see it has like wide range of estimated values. And then what if I want to look at the estimated value versus last sale amount, right? So now this plot, Y is actually last sale amount, and then X is our, so yeah, sometimes like Seaborn takes up a lot of space, so it will just slows down the computer. But the Y is last sale amount, and the X is estimated value. So you can actually see, okay, there's some relationship because of the outliers is not looking so good. So you know what? I will go ahead and I remove the outliers for last sale amount. Last sale amount should be less than, again, or equal to 1 million. So is this the right number? I think I added one more. Okay, so, and then I want to do the same thing as we did before, assign it back to DF. And now I'm going to look at this pair plot again, right? Because the outliers, if you have the outliers, a lot of time it will skew the plots. Now it looks a lot better because we got rid of the outlier. Therefore, you can see the histogram, right? For last sale amount, it looks like somewhat normal, this is a histogram for last sale amount, this is a histogram for estimate value, and this is pretty much the plots or the histogram for zip code, right? But because zip code is not a continuous variable, therefore you'll see the bars like this. Now let's look at, the relationship between estimated value and then last sale amount. It looks somewhat linear, right? With, a huge blob almost, but it's a linear, I would say it's a linear relationship. That means the higher the last sale amount is, the higher the current or the estimated value should be, which kind of makes sense, right? And then the opposite of that is really like, it's this, right? So if we just swap X and Y, so this is the plot. So X now is last sale amount, and then Y is estimated value. So what we're saying is that the higher the last sale amount is, the higher, right, the estimate value is, which, makes sense. And then you can see with the color overlay, a lot of time you can actually draw a lot of interesting conclusions. You can see, okay, the outliers here, like, which means the last sale amount is high, but then the estimate value is not so high. It's coming from green, like somewhat like this, like 80204. That means this zip code is not, is one of the outliers. It's not, just because last sale amount is high doesn't mean that the estimate value is high. Maybe something happened to this area. It could be the crime rate. It could be any other factors that are not really, it's contributing to like the current estimated value. So yeah, there's so many things you can do. And then I added one more thing. It's like Seaborn has like many fancy models, plots you can do. So you can do SNS.strip plot. So now I can see, by zip code, X is my zip code, df.zip code. This is how you can get access or get the field, right, which is zip code from this df, and Y is your estimated value. So this is actually very convenient in a way that you can see by zip code what is the estimated value and then its distribution, right? This is like almost like the scatter plot for every zip code, right? And then you can see, okay, so this one has like, some outliers here, but pretty much, all of them are here, right? And then this one won't have one data point, so it doesn't count. These few, it's like very minor. So it's very convenient. And the other one I will say is CNS.violin plot is very popular as well. You can do almost the same thing. So X is equal to df.zip code, and then Y is equal to df.estimated, right, value. So you can actually look at the violin plot, which might take some time, but it looks like a violin. But these two, only have one data point, so you can't really look at the distribution. So other ones you can actually see, yeah, this one actually has pretty high blue, right, and then pink. These two zip codes have, they tend to have higher estimated value overall. So these could be like more like expensive areas like downtown or very, good areas with good schools. And that's why, the value of the house is actually increasing or higher than other zip codes. But I mean, these are all the things that you can do to look at the statistics, so to really compare the differences and then draw useful insights from your data set. And then, I said something like in here. So I said something like, okay, so let's say you have, so if we just do a quick, info again, right? So df.info, you can actually see all these columns, but the date is not in a date format, right? It's only just a subject format, object format. So we don't want to keep date as a string. We want to convert it to a datetime format, right? Pandas datetime.